Okay, good morning, everyone. Today I'll just review what we learned about 8.6. Probably the most important property we had in 8.6 was the fact that a raised to the m over n is equal, let me clear that up, a raised to the m divided by n is equal to the nth root of a raised to the m, or is equal to the nth root of a raised to the m. So we'll be using that a lot in these problems. So for example, I have the fifth root of 10x to the fourth. So I can write that as 10 times x raised to the fourth, all raised to the fifth, all raised to the 1/5. And then I can distribute exponents to exponents. So I can distribute the 1/5 to the 1, so that would be 10 raised to the 1/5. And I can distribute the 1/5 to the 4, so that would be x raised to the 4/5. Okay, so we're writing these as with rational exponents, going from radical expressions to rational exponents. In here, the next one, I have the cube root of -3 times the fourth root of x, all raised to the 5th. Okay, and so I can write the cube root of -3 as -3 raised to the 1/3, and then I can write the fourth root of x as x raised to the 1/4, and then we raise everything to the 5th. And so I'll just distribute exponents to exponents. So 1/3 times 5 is going to be 5/3, so this would be -3 raised to the 5/3, and then 1/4 times 5 would be 5/4. Simplify each expression by writing as a radical. Okay. So again, I have 16 times x to the third, all raised to the 1/4. So that's going to be the fourth root of 16 times x to the third. And then the largest perfect fourth root factor of 16 is 16. So I'll have the fourth root of 16. And then times the fourth root of x to the third. 4. It can, or any multiple of 4 cannot go into 3, so we can't simplify x to the third. So the fourth root of 16 is 2, and then 2 times the fourth root of x to the third. 3 raised to 3/4 times x raised to 5/4. Again, so I can write that as the fourth root. I can write that as the fourth root of 3 cubed times x to the 5th. Okay. And then the 3 cubed is 27, so this would be and then x to the 5th is x to the 5th, so this would be the fourth root of 27, x to the 5th. And then finally, the last one, I have x raised to 3/5 times 3 times 7, y raised to the 7th, all raised to the 1/5. So because my index is the same, I can put everything under the same radical. So that will be the fifth root of x to the third times 3 times y raised to the 7th. And let's see here, the largest multiple of 5 that goes into 7 will be 5, so I'll have y to the 5th. So the fifth root of y to the 5th, which is just y, and then what's left over is x to the third y squared. All right, so just a little review of this important property that we learned last week. All right, today, a very easy lesson. We'll get into solving radical. Let's see here. We'll get into solving radical equations. No inequalities. Or rational exponents. We'll solve rational exponents as well. Okay, so let's look at this. A radical equation contains a variable within a radical. Recall that you can solve quadratic equations by taking the square root of both sides. For example, if you had x squared equals 20, if you take the square root of both sides, you would get x is equal to plus or minus the square root of 20 is the square root of 4 times the square root of 5, and that will give you plus or minus 2 root 5. So recall you can solve quadratic equations by taking the square root of both sides. Similarly, radical equations can be solved by raising both sides to a power. So let's see here. So we have, first step, we always want to isolate the radical. So I have the cube root of x minus 2. Okay, so to isolate the radical, I add 2 to both sides. And now I can raise both sides of the equation to the power equal to the index of the radical. The index is 3. So if I raise both sides to 3, I'll get x is equal to 2 cubed, or x is equal to 8. And again, just to recall that the cube root of x, well, that's equal to x raised to 1/3. So if I want to get rid of the 1/3, I just raise everything to the 3. 1/3 times 3 is just 1. Okay, for a square root, the index of the radical is 2. So here we go. So solve this equation. So I have 5 plus the square root of x plus 1 equals 16. We want to isolate the radical. So first thing I do is I subtract 5. And then I have x plus 1, the square root of x plus 1 equals 11. So I square both sides. And then I'll get x plus 1 equals 121, or x is equal to 120. Again, isolate the radical first. The next one here, so I have 7 times the cube root of 5x minus 7 equals 84. The first thing I'll do, want to isolate the radical, so you divide by 7. And now I have 5x minus 7 equals 12. And I always like to look at these in terms of rational exponents. So 5x minus 7, that would be raised to the 1/3. The cube root of 5x minus 7 is the same as 5x minus 7 raised to the 1/3 equals 12. And then all you do, you want to get rid of the 1/3, so you raise everything to the 3. You raise everything to the 3rd power. So you get 5x minus 7 equals 128. Add 7, divide by 5, and you get 347. Next one here, okay, the radical is already isolated, so I just I take both sides to the 3rd power. That gets rid of the radical. I'll have 3x minus 4 equals 8. Add 4, divide by 3, and you get 4. And then lastly here, I have the square root of 7x plus 2 equals 3 times the square root of 3x minus 2. Okay, the radicals are isolated on both sides. So what I want to do, you just want to square both sides then. You square both sides. Okay, and that gets rid of the radical. But here you have to remember that you have 3 times the square root of 3x minus 2. So you also have to square the 3. So 3 squared is 9. Okay, so now you have 7x plus 2 equals 9 times 3x minus 2. Distribute the 9. 7x plus 2 equals 27x minus 18. Solve for x, and you get x is equal to 1. Again, the next one, I have the square root of 8x plus 6 equals 3 times the square root of x. So again, the radicals are already isolated. So I square both sides. I'll get x plus 6 equals 9x, and then x is equal to 6. Okay, so now here, rather than working with radicals, we'll be working with rational exponents. Okay, but again, really working with exponents is really no different than working with radicals. Okay, because all we're really doing is we're just rewriting the radical as a rational exponent. Square root of 8x plus 6 is the same as 8x plus 6 raised to the 1/2. Okay. Equals 3 times x raised to the 1/2. And then when we just raise everything to the 2nd, so you get 8x plus 6 equals, you have to distribute the 2 to each exponent, so that's going to be 3 squared times x. And you'll get what you have there. So really no difference. So solve each equation. So again, I have 5x plus 7 raised to 1/3 equals 3. So you want to raise both sides to the 3rd power. You get 5x plus 7 equals 27. You get x is equal to 4. Sometimes, though, you have to be careful. When raising each side of an equation to an even power, you may introduce extraneous solutions, a solution that doesn't make sense. Okay, there we were raising to an odd power. We wouldn't have that. So let's take a look at where we may run into a problem. So here I have 2x is equal to 4x plus 8 all raised to the 1/2. That's the same as the square root of 4x plus 8. Now remember, this here, it has to be 0 or positive. Keep that in mind. That value has to be, you can't take the square root of a negative number. At least with the problems we're working with. We're not working with imaginary numbers or answers. We're working with the real number system. So you can't take the square root of a negative number. Just keep that in mind. So when I square both sides, I'll get 4x squared equals 4x plus 8. And then I have 4x squared minus 4x minus 8 equals 0. And then I have to factor x squared minus x minus 2 after factoring out the 4. And so you get x is equal to 2 or x is equal to negative 1. Okay, now recall I just said here that this here, that right side has to be 0 or positive. Can't be negative. Well, if I substitute in negative 1 for my answer, 2 times negative 1, I get negative 2. Well, that's impossible because the right side has to be 0 or greater. Okay, so we would say negative 1 is an extraneous solution. I get x, so on the left side I would get negative 2. Let's look at some more. Here I have x plus 5 raised to the 1/3 equals 3. So I'll raise both sides to the third power, and you'll get x plus 5 is equal to 27. X is equal to 2. Again, you never have extraneous solutions when it's raised to an odd exponent. And again, the next one, 2x plus 15 raised to the 1/2 equals x. So I want to square both sides. I'll get 2x plus 15 equals x squared. I'll get x squared minus 2x minus 15 equals 0. Factor, you get x minus 5 times x plus 3, and then your zeros are 5 and negative 3. And again, you can exclude negative 3 because, again, 2x plus 15 raised to the 1/2 is the same as the square root of 2x plus 15, and it has to be either positive or 0. So x equals negative 3 is not a possibility. The left side has to equal the right side, but the right side here you're saying can be negative 3, but the left side cannot be negative. All right, so there. So pretty easy to do, solving radical equations or rational exponents. They're all one and the same, but pretty easy lesson. So your lesson quiz will be these problems here.